started. I'm going to make sure that I am recording from here on out. Okay, so thank you guys so much for being here today. I hope you all have, thank you for putting your attendance in. I saw you guys did that very quickly today. I appreciate that. Um, you guys were all here for the attendance policy talk on Monday, so I don't really need to go over it, but I will mention again that remember that work has to be done um, on the days that I see you Monday and Wednesday, or you have to come to class at the very least to get credit for the day. And let's go ahead and show our Schoology course in Chrome. Okay, so here we are in Schoology for week 2. Notice that everything has a date and time associated with it to make sure you guys are getting credit for the day. Everybody got credit on Monday, so no worries about that. Everybody got their full credit because we didn't finish our notes, so everybody got full credit anyway. So for your practice number 1 and number 2, number 2 should be turned in today by 7 p.m. to get credit for the afternoon class, okay? So either that or the exit ticket has to be turned in today by 7 p.m. for you to get credit for the afternoon period, all right? That's it. That's really all the announcements I think I have. Oh wait, yes. The other thing is that in your homeroom course, so look for the daytime homeroom, you will see the trivia questions have been posted. And you can answer these trivia questions, all right, and email the answers to Ms. Koya in order to get entered for the gift card. So make sure you go to the, again, homeroom course. That's where you would get that information for that. It's going to be posted every Monday. This time it was posted yesterday because of Ms. Koya not being ready on Monday. So she's not posted it on Tuesday, but it's there. And you guys will be entered for a chance to win a gift card or whatever the situation is. I'm not really exactly sure how that works, but that's what's happening from now on. Every week on Monday, you can answer trivia questions to get a chance at a gift card. All right, let's go back to our PowerPoint slide because that's what we're working on. Okay, so today we're gonna finish our notes. But before we get to our notes, I wanted to take a look at this question that we have here about taking a taxi. And so if we're taking a taxi and it costs $3 plus an additional $2 per mile travel, you spent exactly $20 on a taxi, which includes a $1 tip. So how many miles did you travel? So go ahead and try to work that out on your own. Use paper and pencil. Try not to use a calculator. And then if you have an answer, put it in the chat. I'll give you a couple minutes to work on that.
share thing away. What is chat? Oh, right.
All right, so let's try this question together because it's definitely left you all a little confused. All right, so to take a taxi, it costs $3 plus an additional $2 per mile traveled. If you spent exactly $20 on a taxi, which includes the $1 tip, how many miles did you travel? So we know that the flat fee is $3. We know that I tipped $1, right? So we have to take that money into consideration, right? So it seems that like the answer at least was correct, but maybe the process maybe was a little off. So let's make sure that we're understanding that, right? So it's $20 total, right? That's how much I spent on this taxi. I have to subtract $1 for how much I'm tipping, and then subtract $3 for the flat fee, right? So $20 minus $1 minus $3, that's gonna leave me with $16, okay? So $16 it costs me to travel based on distance. If I'm charged $2 per mile, how many miles did I travel? You need to do 16 divided by 2 to get 8 miles. Okay, so I saw the 8 miles in the answer, but I saw that the process seemed to be off. So this is the process. This is what you should be doing to get your 8 miles, right? You have to take away the tip, as that's a flat. It's not going to be changed based on distance. That $3 was also a flat fee, right? $3 is how much it costs. That's the flat fee. $2 per mile is what changes based on how many miles I go. So now that I have the $16, I divide that by $2 per mile to get 8 miles, okay? So 8 miles is how far I traveled. Okay, so this one is 8 miles. That's how many miles I traveled on this trip. Okay, very, very good. Okay, so we are gonna do next, what we're gonna do next is make sure that we are finishing up our notes. So we started our our notes on Monday. We're going to finish them today. So I'm just going to make sure I pull open my copy of the notes. Make sure you have your notes open as well. And we're going to do essentially just pages 5 and 6 of those notes. Apologize, my files are not where I want them to be right now. Give me a second. Okay, here we go. This is the file that I was looking for. Okay, so we're gonna start with page 5 of your notes. Let me go ahead and clear all my drawings. We're gonna do a new share. All right, so we're on page 5 of your notes. We're comparing and ordering rational numbers. All right, so just some further notes on making sure we understand how to compare them. So when ordering negative numbers, the smallest number is the one that is furthest from 0, okay? When ordering negative numbers, the smallest number is the one that is furthest, right? The word here is furthest from 0. When ordering negative number, the smallest numbers are the numbers that are furthest from 0. So that means that if we are to graph negative 0.2 and negative 4/5 and then compare them, the one that is furthest away from 0, that means most to the left from 0, is the number that is the smallest number. Okay, so on this number line, we have 0.5, 0, we have negative 0.5, 0, positive 0.5. If we have negative 0.2, we know that that's going to be over here, right, in between the 0 and the negative 0.5. If we count, we'll see that there are 1, 2, 3, 4, 5 spaces from 0 to 0.5. That means that every one of these marks represents negative 0.1. So that's negative 0.1. That means that right here is negative 0.2. That one was easy to find. This is negative 0.2. So because my number line is already in decimals, right? In order to graph negative 4/5, I'm going to have to turn that into a decimal. So who remembers from Monday, how do I turn a fraction into a decimal? How do I turn that into a decimal?
Divide.
Good. I have to divide the numerator by the denominator. So I have to do 5 into 4. And remember, it's negative, right? It's a negative, so my answer is going to be negative. Okay, so 5 can't go into 4, so I need to add a decimal and a 0. But now I have 40. So how many times does 5 go into 40?
8.
8 times. So the decimal version of negative 4/5 is negative 0.8. So again, I know that all of these little hash marks in blue are represented by a negative 0.1. So this is negative 0.3, negative 0.4, negative 0.5, negative 0.6, negative 0.7, negative 0.8. So this is negative 0.8 here, right? Or I can represent it the way that They gave it to me, -4/5. So again, that means that the ones that are furthest from 0 is the smallest number. So the ones most to the left are the smallest number, and -4/5 then is smaller than -0.2. So when I compare them, I'm going to say -0.2 is greater than -4/5. Okay. This is how I compare. I can use my symbols of less than or greater than to compare. And remember, your mouth should always be pointing to the number that is bigger, right? Because the mouth is hungry. And when you're hungry, you're not trying to eat small food, you're trying to eat as much food as possible. So the mouth, or the part that is open, that's the part that should be pointing towards the number that is bigger. All right, so we did that one, right? And so now we're going to try number 2. For number 2, we have 1, 2, 3, 4, 5 numbers to graph. Okay, so let's start with the easy numbers, meaning that we have 3 negative numbers. So we're going to save these for last, these negative numbers here. We're going to save those for last because we have to put those in order. But the 0 and the 3/4, as they're not negative, they're going to be easier to figure out, right? Well, we know exactly where the 0 is, so we can just go ahead and graph the 0. We just try to put the dot right here. The 0 is already marked for us. That's very easy. There's our 0. So now we have to think about 3/4. Well, 3/4, because it's the only positive number up here. Remember, 0 is neither positive nor negative. It's nothing. It's just 0, right? So 3/4, because it's the only positive number up here, we know it has to be to the right of the 0. Okay, so 3/4, right? We can represent 3/4 by trying to figure out how we're counting in our hash marks. So how many spaces are there, or how many hash marks are there between 0 and 1? Remember that we start counting with the hash mark after the 0. So 1, 2, 3. We're not at 1 yet, right? So we can't stop here. We can't stop here and say it's only 3 hash marks. To count all the way until we get to 1, that means there are 4 hash marks. That means that the separation between 0 and 1 are divided into fourths, right? So we already have fourths written out here. This division is by fourths. So if we need to count 3/4, we just have to count 3 hash marks from 0. So 1, 2, 3. So this right here is 3/4. All right, so now I've labeled 0. I've labeled 3/4. So now we have to work with the negative numbers, and I'm going to rewrite them over here so that I can keep track of them. I want to keep track of my negative numbers. I don't want to lose them. So let me write my negative numbers over here. I have -1 2/5. I have -2.3 and -1 9/10. Okay, so which one of these 3 is not like the others? Which one is different? Which one doesn't belong? Of these 3, which one is the most different?
-2.3.
Good. -2.3 is the most different, right? It is a decimal, right? 1. But it also has 2 as its whole number. So this one is going to be the easiest one to plot next because it's the most different. I know that as it says -2.3, that means that this one is to the left of 2. It's further away from 0 than 2. So it's over here somewhere. I know it's in this zone, right? So I know that it's over here somewhere in this zone. These other 2 are more similar, right? And so they are in relatively the same zone. So they're going to be harder to plot. So let's plot this one first, -2.3. 3. Okay, so all of these marks here are quarters, right? So this is -2 1/4, -2 2 2/4, -2 3/4, right? These, again, they're still quarters. They're the same measurement, same distance. So how do I figure out where this 0.3 goes? Well, I need to figure out, or I need to understand the difference between each of my quarters, right? And the way to think about it, of course, is to think about the decimal equivalents of these quarters. And you already know that. You know it without even thinking, without even doing any math. I do not need to convert these using math, because how much change is in a quarter? How much cents is in a quarter?
4.
How much cents is in a quarter?
How much cents?
Yeah.
25 cents.
25 cents, right? How do I represent 25 cents? 0.25, right? How many cents are in 2 quarters?
50.
How do I represent 50 cents? 0.50, right? 3 quarters, 0.75. So that means that -2.3 has to come between 1 quarter and 2 quarters, right? Because that's what 2.3 means. 2.3 means it's going to be not directly on the quarter, but a little bit after. So I'm going to put my dot in between the 1 quarter and the 2 quarters, or 1/2, right? I'm going to put it right here, right after, pretty close to the quarter, but not on it, right? And this is -2.3, right? -1, -2, -2.3, and then -3, right? That's the order it definitely should go in, right? So there's my -2.3. So I plotted that one. Now I have to deal with these other two. These other two are more similar because they're both going to be in the zone in between -1 and -2. How do I know that? Well, because they both have -1 as their whole number, right? So I know that both of them are going to be in between -1 and -2. So again, I have to do the same thing. I have to do a similar thing that I did with kind of my decimals. I have to figure out where 2/5 fits in with these fractions: 1/4, 2 quarters, 3 quarters, right? Is it bigger or smaller? And how do I know? Well, the easiest way is going to be for me to convert this 2/5 into a decimal. The other way would be to compare it to each of the fractions, right? When I compare it, I can just cross multiply, right? That's one way to do it. And think about it, but I have to do it for each of the fractions, right? That's going to be a harder thing to do if I have to do it 3 times versus just converting it once. So how many times does 5 go into 2? 5 can't go into 2. We add a decimal and a 0. How many times does 5 go into 20?
4.
It goes in 4 times. So this is 0.4. Where does 0.4 fit? 0.4 fits in between 0.25 and 0.5. So it's going to be, that's where I'm going to plot -1 and 2/5. I have to find my -1 1/4, -1 and 2 quarters, and put it in the middle here. A little bit closer to the 5 than the 2. And we plot it. We just say -1 and 2/5. All right, so now we're going to do the same thing for 9/10. 9/10, we should automatically know what 9/10 is as a decimal, but if you don't remember, you can go ahead and do the division, right? But 10 goes into 90.9 times, right? 9/10 is 9/10. How do we represent 9/10? As a fraction or just as 0.9? This is also 9/10, right? So 0.9 is after 0.75. So in between 1.75 or 1 3/4 and 2 is where I would plot my last number, which is -1 9/10. Okay, so now that I've plot all my numbers, I can see that the order from smallest to biggest, right, for least to greatest is -2.3, -1 9/10, -1 2/5, 0, and last is 3/4. That's my order from least, smallest, to greatest, biggest. Okay. And the reason that we're graphing and ordering these numbers is because we need to be able to compare decimals to fractions and fractions to decimals. We also need to be able to go back and forth between the two. All right, so this is what this week has been really about, is making sure that we can compare them. Next week, we're going to work exclusively on fractions, just like we did last week, work exclusively on decimals. Next week will be exclusively on fractions, right? And we know that there's a lot of work with fractions, so be prepared for all the heavy fraction work, right? When we're adding fractions, it's a lot of work, so we have to make sure that we get all those steps. And then, of course, multiplying and dividing fractions are a breeze, but we have to make sure that we are ready for that, okay? We're doing this work with these rational numbers now so that we're comfortable with them when we see them in the future, because we see them all the time. And we don't want to have to pause and think about, well, oh, now I need to teach how to work with fractions, right? It's always going to apply from here on out, that work. And it's not like I need you to memorize it, but I need you to be more comfortable as we work through it. So this is like the introduction, right, to working with these on a bigger and deeper level, right? So if it seems easy now, that's great. If it seems difficult now, what we have to do is continue to work through it, right? We have to make sure that we keep doing the practices, all right? And so hopefully these practices that I've assigned to you will help you as you work and develop your skills better with these fractions and with these decimals. All right, let me review really quickly what we've done today so far, right? We've recognized that when we're ordering a negative number, right, we always have to make sure and understand that the smallest number is the number that is furthest away from 0, more to the left, right? The more to the left you are, the smaller you are, right? That's how number lines work in general. The more to the left you are, the smaller you are, okay? But especially with negative numbers, even though this number looks bigger, like 2.3 is a bigger number than 1 point anything, but because it's negative, it's actually smaller. I owe $2. I don't have $2. I owe it. So I'm in the hole. I'm negative. Okay. And so negative 2.3 is going to be further down on the number line than negative 1 9/10, which is further down in a number line from -1 2/5, which is further down from 0, and further down from 3/4. Okay. So this is how we read it, left to right, least to greatest. I know my hands are disappearing. So yeah, that's how we work through those. Questions and comments? Alrighty. All right, our last page of our notes is what we're going to go over now. Okay. I apologize for all the construction noise in the background. It's been annoying me since 7 o'clock this morning, so you can only imagine what I've been going through. Okay, so it says to put the numbers below in ascending or ascending order. What does ascending order mean? What's ascending order? Who knows what ascending order means? Who knows what that vocab word is, ascending? What does it mean to ascend?
Ascending is small to big.
Very good, yes. Ascending is from, we're gonna use our math terms, but yes, small to big is correct, right? From least to greatest. When I ascend, I go up. Think about climbing a mountain. I'm ascending, right? I start from the flat surface and I go up. That's ascending, okay? Okay, so we have these numbers here that we need to put in ascending order. So we're going to start with the smallest number and then go all the way up to the biggest number. But as we can see, we have a mix of decimals and we have fractions. Wahahaha. Okay, so we have, in order to really make them equivalent, we need to make them all into decimals. So how do we turn -2 5/8 into a decimal? Of course, we have to divide, right? So what is 5/8 as a decimal? Work on that. What is 5/8 as a decimal? You can put your answer in the chat. You can shout it out if you find it quickly, but what is 5/8 as a decimal? Remember, that means you have to do 8 into 5. How many times does 8 go into 5? Eight can't go into 5, so I have to add a decimal and a 0. But 8 can go into 50. How many times does 8 go into 50?
7 times.
8 goes into 50 6 times. 7 times would be too much because 8 times 6 is 48, right? And so then I have 2 left. I need to add another 0 and bring that down. So then 8 will go into 20 2 times. That gives me 16. And then I add a 4 and I add my final 0 so that I have 40 and it goes in 5 times. Okay, so you're never going to have to go past the third decimal for me unless I really need you to for some crazy reason. But 5/8 is equal to 0.625. So we're going to put the 625 right here on this line. So -2 5/8 is equivalent to -2.625. So I'll chat. Let's see what the chat says. Good. Good. Okay. All right, and then now we have to convert 720 the same way. We need to convert 720 into a decimal. So let's also do that. Let's convert 720 into a decimal. I'm not going to erase, I'm just going to put it over here. Again, we're going to do 20 into 7, which I can't do. So I make it 70. 20 goes into 70 3 times to give me 60. I have 10 left over. I add another 0 and I bring that down. So now I have 20 into 100, which is 5. Right? 20 goes into 100 5 times. So I have 0.35. So 2 7/10 is equal to 2 3/5. Right? Okay, great. So now we have all the information we need to put these in order from the least, the smallest, to the greatest. So which number is the smallest out of these 5? Which is the smallest number? Negative what?
Negative 2.7.
Negative 2.7 is the smallest. And then we have what? Negative
2.625.
625, yep. Or 2 and 5/8. I'm gonna write it the way that they gave it to us originally. But yes, negative 2.625, yep, would be next. And then after that, negative 1.74, perfect. And then what's next?
2.35.
Good, 2.35 or 2 and 7/20. And then of course the last one is 2.35. Okay, good. So ascending order means to put it in order from least to greatest. So anytime you see ascending, think going up from small to big.
No, the last one is 2.4.
Excuse me, yes, that's right. I apologize. Let me erase that. Yes, it's 2.4, not 2.35. 2 and 7/20 and 2.35 are the same number. It is 2.4. Okay, great. All right, so remember, ascending means to be going up. And then, all right, cool. Okay, so now what does descending mean then? What does it mean to descend? Well, descend has to be the opposite of ascend, right? So we have to go from big to small or from greatest to least. Okay, so when we're doing it in descending order, we're doing it from greatest to least. I'm actually going to erase all of this so I can move my file up so you guys can see it better. Okay, and I'm going to put it back in. Okay, so from greatest to least. All right, so we have the same complication that we had before. We have some decimals and some fractions. So we're going to turn all of our fractions into decimals. So 1/3 we're going to turn into a decimal. And we will see that this is a special case, right? When we're dividing 1 by 3, of course, we turn it into 10, and we're going to get 3 times it goes in, and then we're going to get 1. We're going to add another 0. We're going to bring it, it's going to be 10 again. It's going to just keep repeating, right? So we can just leave it as 0.33. We don't need to do all of these 3's behind it. It's just going to keep repeating. So remember, you can always stop at the 3rd decimal place for me, and then you can round. So it's 33, right? The next number is a 3. It's not going to go any higher than 3. It's just 0.33. That's fine. So negative 32 1/3 is equal to negative 32.33. And then negative 33 3/20. So 3/20, we have to divide 20 into 3. It's not going to go. So it's 30. So how many times does 20 go into 30? It'll go in 1 time.
20,
You're going to get 10 left. Bring it down. So 20 goes into 100 5 times. Okay, so it's 0.15. All right, now we have all of our information that we need to put it in order from greatest to least. So which number is the biggest number? This is going to be the number that is closest to 0. That's going to be your biggest number because they're all negative. So which is our biggest number? It's going to be negative because they're all negative. They're all negative numbers. So which one is the biggest number? They're all very
32.2.
Perfect. This is our biggest number, negative 32.2. Perfect.
The second one.
All right, so now which one is our next biggest number? Negative 30 what?
$32.25.
Negative.
Negative.
So this one is negative 33.25.
Yeah.
So that's not going to be next. Which one is going to be next?
Oh, okay. Mm, 32.3.
Yep, good. Negative 32.3.
Okay.
Good. All right.
32.33.
Very good. Or negative 32 and a third. Yep. All right.
33.25 now.
So our next biggest one is going to be negative 33 and 3/20ths, right? Because only 0.15, right? Versus 0.25. This is a smaller number.
That's the biggest one.
Yeah. So 33 and 3/20ths. And then the last one, negative 33.25. Okay. Okay, so descending means to come back down the mountain. I'm going from the biggest to the smallest. Again, it's going to be easier to compare my numbers once I have them all as decimals. So this is what I did here. I made sure to convert them by dividing the numerator by the denominator. Right? When my answer continues to repeat, I'm done, right? It's just 0.33. I can round if I need to round. In this case, I don't need to round it up because it's just going to keep being threes. And then once I've figured out my decimal equivalents, and then I can now put it in order, okay? So remember that the number closest to 0 is going to be the biggest. The number furthest from 0 is going to be your smallest when we're dealing with negative numbers. All right. What are your questions for me? All right, we're going to do these two examples. Then we're going to review your assignments that you need to complete. And then we're going to go into our GED practice question for today. Okay, well, our additional GED practice question, because we, of course, started off with one. Okay, so we're looking at number 1 here on the right. It says Brenda correctly ordered the positive rational numbers below. If Brenda is given the opposite of each number, how should she order them from least to greatest? Okay, so we're putting these numbers here, the opposites, in order. So how do we put them in order from least to greatest? What's my first step going to be in order to get these numbers in order? What's my first step?
First step is to transform fraction in decimal.
Good. Convert my fractions to decimals. Whenever you guys are working with mixed fractions and decimals, always convert first, all right? We can convert to either. It's going to be easier if we do fractions to decimals, okay? After I've converted my fractions to decimals, right, then I want to order them, right? From smallest to long. Then I'm going to do them in ascending order, okay? Then I should order them ascending, right? Right, from smallest to biggest. All right, so let's do those steps. Let's convert these fractions to decimals, the first thing. So we already have, we know 5/8. We actually just did 5/8 not too long ago, right? 5/8 is equal to 0.625. We just did that. So we have negative 5.625. All right, so now the next one we need to do is 15/20. So 15/20, we can divide it directly, 20 into 15, or we can reduce it first by 5 to get 3/4. And if we use 3/4, we should know that 3/4 is 0.75. So if it can be reduced, maybe you reduce it before just directly dividing, okay? Because that might save you some time. Because I know what 3/4 is. I don't know what 15/20 is as a fraction, as a decimal, but I know what 3/4 is as a decimal. Okay, so we have negative 6.75. All right, so now we have all the information to put them in order from smallest to biggest. So which number is the smallest here? Which number is the smallest? All right, so our smallest number is going to be the number that is furthest away from 0. And in this case, our smallest number is negative 6.8. That's our smallest number. Negative 6.8 is our smallest number. What's next? What's our next smallest number?
6.75.
Good. Yep. Or negative 6 and 15/20. You can write it either way. I'm going to write it with the fraction the way that they gave it to us. So negative 6 and 15/20. All right. Which number is next?
6.74.
Perfect. 6.74 is going to give us our next number. Negative 6.74. All right, which one is next after that?
5.625.
Good, negative 5.625, right? Oh, excuse me. I'm gonna undo that. I'm gonna write it with the fraction. So it's negative 5 and 5/8. And then the last one then is negative 5.3, right? And this should make sense to you that this is the correct order because as you can see, she put it in order when they were positive, right? And 5.3 was the smallest and 6.8 was the biggest from least to greatest. So when I make it negative, it should be the opposite and it is the exact opposite, okay? All right, so when I do it with the opposite numbers, this is now my order. Negative 6.8 is now my smallest, and negative 5.3 is now my biggest. It should be the opposite because they're now negative numbers. All right. Any further questions about this? We'll just do number 2. We'll go over the assignments you all need to do for me, and then we'll do our GED practice question. Okay, let's move this up a little bit so that I get the question in full view. I'm going to clear all of my drawings. All right, so it says Brian and Sarah are discussing how to compare fractions, the fractions negative 5/6 and negative 5/7. Brian says that negative 5/7 is smaller because negative 5/7, I'm sorry, Brian says that negative 2/7 is smaller because negative 2/7 is less than a half, and negative 5/6 is more than a half. Sarah says that negative 5/6 is smaller because it's closer to negative 1. Which student is correct? Who is correct, Brian or Sarah? Which fraction is smaller? Which one is smaller? And how do we know?
Negative 27, negative 5/6 is negative 5/6 is smaller than negative 2/7.
Okay, good. And we know that there's a couple ways for us to know that, right? One way is to use our regular way of comparing fractions where we cross multiply, right? So we have 6 times negative 2, this gives me negative 12. We have to remember to keep that negative or else we're gonna get the wrong answer, right? And then we have 7 times negative 5, which gives me negative 35. Which one is a bigger negative number? Negative 35 is a bigger negative number. That means that this fraction is smaller, right? Okay, that's one way to do it. But the problem with doing it like that is that we might forget to include our negatives and we'll get 12 and 35 and we'll say, oh, well, 35 is a bigger number. So this must be the bigger fraction and therefore negative 2/7 is smaller, right? But when we include our negatives, we'll see that this is actually the smaller fraction. So that's one way. But if that confuses you looking at those fractions that way, of course, you always have the option to divide each one, right? And use your division in order to get your answer. So in this case, I would use 8. I would get a 2, 0, and bring that down. So then that's 3 for 18, and then it's going to keep repeating. So it's 0.883, so negative 0.833, and then 7 into 2. Again, it's going to be the similar situation. You're going to get 2, 14, gives me 6 and 60. 8 is 56. That gives me a 4. And then 5 for 35. Okay. Sorry, 1 second. And so about approximately, I'm just going to round it because it keeps going and going and going. So it's negative 2.86. So which of those two numbers is smaller? This one is smaller, right? Because it's a much larger negative. So negative 5/6 is our smaller fraction. So Sarah is correct. Okay. So we can say they're correct by using the comparison here of our two fractions. Right, I saw a chat. Somebody just chatted me. Okay. All right, y'all. So that is the last example. Do we have questions about that last example? We're just going to go over your practices in Schoology, and then we're going to do our GED question to end the day.
Is on Schoology?
Yeah, we're going to go back to Schoology. Yeah. All right, let me show you what we're working on in Schoology. Let me just stop sharing for a second. So many things. Open. Nope, okay. Good, that's what I thought. I'm in the wrong class. Okay, so now I can share my screen again. Okay, so in Schoology, we have these two practices, right? Practice number 1 and practice number 2. If you're not in the live class, you do need to submit practice number 1 by 7 o'clock today to get credit. Since you guys are here in the live class, what you have to do to get credit for the 1 o'clock time period, you have to submit practice number 2. So let's go over practice number 2 first, or you can do your exit ticket, either one, but I would rather you do practice 2. So let me just open up practice 2 and let's take a look at practice 2 together, so we can make sure you guys know how to do that. So practice 2 is about comparing and ordering fractions, which is what we were doing on Monday. So I just want to go over those steps and do a couple examples with you really quick. And then you guys need to do the rest and submit it by 7 p.m. today to get credit for that 1 o'clock period. Okay, yes, we're ready. Okay, so again, when we compare fractions, all we're doing is cross multiplying. So 5 times 1 gives me 5. 3 times 3 gives me 9. This 9 is bigger, so that means when I compare these fractions, I'm going to write this symbol, right? 3/5 is greater than 1/3. Okay, I will do the same thing for, let's just go over here to this one. We do 1,000 times 21. I'm going to get 21,000, pretty big number. 205 times 100, though, is going to give me 20,500. Right? So which one is bigger? This number is bigger. That means that is how I compare those two fractions. All right? Comparing fractions are pretty straightforward, right? But what happens when I have 4 of them, like at the bottom here? It's still going to be the exact same thing, right? I just have to know which numbers to compare to which ones, right? I should know that I'm not going to have to do any work to compare 1/4 to 1/3. They both have the same numerator and different denominators. 1/4 is definitely smaller than 1/3, right? Same thing if I have 2/5 and 2/10. 2/10 is smaller than 2/5. Okay, because if I have a pizza and I want 2 slices of it, it's great if you cut that whole pizza into 5 slices and give me 2, rather than cut it into 10 and give me 2, right? Okay, so I know how to compare those two to each other. So what I really need to do is compare 1/3 and 2/5. So I'll do 1/3 and 2/5, and I'll do my same thing, cross multiply, right? I get 6 and I get 5. So now which one is bigger? 2/5 is bigger. So 2/5 is my biggest fraction because it's bigger than 1/3. I know 1/3 is bigger than 1/4, and 2/5 is already bigger than 2/10. Okay, so now again, I'll compare 1/4 and 2/10 to see which one is bigger and which one is smaller. This is 8, this is 10. 1/4 is bigger than 2/10, right? So I know that my order is going to be like this, from smallest to biggest. 2/10 is already smaller than 2/5. I just figured out that 2/10 is smaller than 1/4, and I know that 1/4 is smaller than 1/3. So I only have to do 2 comparisons to get my order. All right, so my order, I will write it so it's clearer, is 2/10, 1/4, 1/3, and finally 2/5. All right, so this is your assignment that I need you all to complete today. So make sure you guys work through that. Let me know if you have any questions, but comparing fractions is all about the cross multiplying. So use Kami to do this assignment for me, and hopefully it goes well. I'm sure you guys will do splendidly. because you guys are super smart. Super smart students.
I got a question. Okay, does mean this the crossing is the this the I want to say that this is the short way.
To compare, yeah, absolutely. That's the shorter way to compare.
Okay, that's mean by converting in decimal, that's the long way.
Yes, absolutely.
Okay.
Yeah. You only want to convert to decimals when you have decimals already there that you're comparing it to, right? Otherwise, you want to leave it as fractions and just cross multiply to compare. Yeah, that's a good question. Yep. Okay, so that's practice 2. Let's take a look at practice 1. Oh, wait, oh. I can't hear you, Tishel, but yes, I see your hand up. I see your hand. I cannot hear you. I'm getting a lot of feedback from your computer, I think. I'm not sure what's going on. But if you're copying it down, I'll let you copy it down. If you have a question, you might want to type it in the chat because I can't hear you for whatever reason. It's just sounding like static, like when you're like not tuned into a radio station. I see your mouth moving, but I don't hear nothing. Okay, here we go. So one or the other today. I want you to do both of them, but for today, one or the other. Good question to show. Yeah, either this practice number 2, or the exit ticket need to be done today in order for me to give you guys attendance for the 1 o'clock time period. Okay, so by 7 o'clock, either one or the other. It doesn't matter which one, but by 7 o'clock. Good question. Okay, so now let's take a look at the other practice, just so I know that I've shown it to you. Just to make sure you guys don't have any questions about how to do it. So the other one, I'm pretty sure you're working with decimals, right? Okay, so this one is just about comparing your decimals, and we've already done a lot of work with your decimals, so you guys should just be using your place value to figure out which ones are bigger and smaller when it comes to your decimals. Let's see, is there anything particularly difficult? No. So let's just do number 2, for instance, together. All right, so I can make it a little bit bigger. I know it's a little small. Okay, so let's work on number 2. So I have 0.51, 0.75, 0.35, 0.475, 0.2, and 0.895. So they're all positive numbers, and I'm putting them on this number line from 0 to 1, right? So to make my life easier, what I should do is just find a midpoint and put a midpoint in there just so I have something to work with. So I'm just going to find a midpoint, so about halfway through, and I'm going to draw a line to just indicate that that's half, right? So for me, that's 1/2. And that's just going to help me decide where my numbers go, because some of them are going to go before the half and some are going to go after the half. All right. So now, which number is my smallest number of these? The smallest number of these, and I'm going to go ahead and answer because I don't want to put Jules on the spot, because I know only, good, it is 0.2, good. Good. Tishel is actually pretty quick with typing, so that's fine. Yes, she can respond via typing. She'll also respond quickly. Okay, so my smallest one is 0.2. So my 0.2 is going to be closest to my 0, but it's going to be before the half. I'm actually going to cut that in half and then put my 0.2 right about here. Again, it doesn't have to be exact, but I'm going to put my 0.2 right about here, 0.2. All right. What's next after my 0.2? What number should I plot next?
$35. 135.
Yep, 0.35 is going to be my next number. Perfect. So 0.35 is my next number. I'm going to put that on here as well. So if I do it correctly, I'm going to really be thinking about, okay, like what's right after, like right about here or so is where I want to put my 0.35. It doesn't have to be perfect, but your 0.35 is going to go right about there. Okay. Okay, and now we have 0.475. We know that this is 0.5, so 0.475 needs to become right before the 0.5. So 0.475. Okay. And then next we have 0.51, which means it's going to come right after the half. 0.51. All right, and in between the half and the 1, right in the middle of that is where your 0.75 should appear. And then after the 0.75 is where the 0.895 should go. Just somewhere after, it doesn't have to be perfect, but right about here maybe is going to be 0.895. Okay. So that gives you an idea of what you're doing for assignment number 1. Assignment number 1, you're only working with decimals. You're only comparing and ordering decimals, okay? And so from smallest to biggest, you have 0.2, 0.35, 0.475, 0.51, 0.75, and then 0.895. All right, so those are your assignments. They're pretty easy and straightforward. So I just wanted you guys to be getting used to comparing and ordering your decimals, getting a good idea of working with your place value, and a good idea of converting back and forth. In your exit ticket, you're going to have to do a little bit more conversion, but you should be fine with it based on the notes. Always review your notes if there's any problems. All right, so we're going to do our last thing for today, and I'm going to let you guys have enough time to go in and finish your practices before you submit them to me before 7. You're gonna have about 10 minutes at the end of the class to get a jump start on that work. I'm just gonna show you one more thing before I let you all go. Okay, so I have a practice question for you. We need to arrange these fractions from least to greatest. Oof. Why, Mr. G? Why are you doing this to us? So how do I do that from least to greatest? You will notice something very unique about these fractions. All of these fractions are actually improper fractions. That means that the numerator is bigger than the denominator. So that means they all have a value over 1. That actually might be a good hint as to what the best way is to put them in order. Maybe you shouldn't use the improper fraction. Maybe you can make them a mixed fraction. I don't know, maybe. Anyway, I'm just gonna give you guys a couple minutes to think through it, see if you have the right answer. You don't have to write it in the chat. You can just keep it to yourself for now. We're gonna try to go over it together in 2 minutes. We're gonna give you 2 minutes of silence for you to think about it. All right. So I'm back, but I'm just back with a hint. I'm not necessarily back to get answers yet. I am going to give you a hint on to how to do this better, right? Or not better, but maybe more effectively. So for instance, if I start with what might be my smallest one, which is 3/2, right? I can convert this into a mixed number by doing division, right? How many times does 2 go into 3? 1 time. I subtract my 2, I have 1 as my remainder. So this as a mixed number is 1 and 1/2. That might be easier for me to deal with instead of these improper fractions, is thinking about them as mixed numbers. So I'm going to give you that hint and then walk away and see if that helps. Okay, so I'm going to try it again. I'm going to do 5/7, right? Or 7/5, I mean, and convert that into a mixed number instead.
I got my order.
You have your order? Okay, what's the smallest one?
The smallest one is a 3.5, 3.2.
3/2 is the smallest?
Yeah, 3/2. Yeah.
All right, let's do a comparison real quick, right? 7/2 and 3/2. 7/5, all right, 7/5 and 3/2. What's 5 times 3?
15.
15. What's 2 times 7?
14.
14.
14.
Which one is smaller? 14.
7.
So 7/5 is smaller than 3/2. So this one is our smallest. Our smallest one is definitely 7/5. 7/5 is our smallest one. Okay, and again, the way that I did it is I converted them all to mixed numbers first because that was easier for me because I can look at the whole number and that really helped me out. So 1 2/5 is smaller than 1.5 because 2/5 is smaller than 1/2. Okay, so let me try that with all of them. Let me see if I convert all of them, if that might make it easier for me to take a look at. So I'm going to do that over here. I'm going to try to convert them all. So 4 goes into 15, right? 4 goes into 15 3 times. I have 3 left over, so I have 3 3/4. That's my second number here, 3 3/4. Okay, 4 goes into 11. How many times? 4 goes into 11 twice. I have 8 and 3 left. 2 and 3/4 is this number. And 3 goes into 13. How many times? 3 times 4 is 12. And I have 1, so I have 4 and 1/3. Okay. So now by using these whole numbers, it's a lot easier for me to put them in order. So 7/5 is the smallest, then 3/2, okay? And then the next smallest is gonna be the 2 and 3/4 or 11/4, then 15/4, and finally 13/3.
Oh my God, I got it right.
You got it right? Yeah. Good to hear. Okay, so this is literally, again, another question directly from a past GED, right? And you can see if we use our same concepts that we learned with other numbers, we can apply it here. But in this case, it might have been easier, instead of just directly comparing them, was converting them to mixed numbers first so that we can see that whole number. That whole number makes a big difference, right? By seeing 3 and 3/4, that's really different than seeing 15/4. It helps me to really understand how big that number is, okay? So just a piece of advice that you can always do that, right? Don't feel like you have to be in this box that they're giving you, right? Remember that you have years and years of math knowledge that you can use in any way that might help you out, okay? So that's just a strategy to how to solve this problem, but this is the order from least to greatest: 7/5, then 3/2, then 11/4, then 15/4, then 13/3. All right. All right. Any last questions for me before I release you guys into the world? I will see Jules on Friday for science, and I'll see Antoinette and Tashelle on Monday for math. Ladies,
I have a question.
Yep.
In the town hall meeting, she was like, just like the teacher, if you can get a tutor, can you give me a tutor so
Yes.
I can tutor if I don't have class?
Yep, absolutely. I will contact our volunteer coordinator and put your name in. I know that Tashelle, you also want one, right? Do you want to keep Elena? Yeah, okay. All right, I will check with him and get you guys those tutors. Yep, absolutely. All right, so ladies, you guys have a great weekend. Do your practices. If you run into any problems, please contact me, okay? And I will see Jules on Friday. All right. Bye, y'all.
Bye.